Good afternoon. We will start the program by 1:30 as per the Indian standard.
Hello, am I audible to you?
Yes, sir.
Is my screen visible? Yes.
Yes, sir, you are visible.
It's in PPT mode or only this one?
It's in PPT mode, sir.
Okay. Can you hear the sound?
No, sir.
Okay. Check now.
Yes, sir. All right.
Okay. Thank you. Ashwin sir, you are not audible.
Hello, sir. Am I audible?
Yes, ma'am. Yes. Mayur sir, you're on mute.
Hello, sir. Good morning, Dr. Sagar. Welcome.
Morning, Dr. Mayur. How are you?
Yeah, good, sir. And welcome to these uh, faculty development programs, basically.
Thank you.
Yeah.
Thank you very much.
Yeah, we'll start, sir. Sir, we'll start this session soon. Okay, sir.
Yeah, no
Yes.
problem. No problem. Take your time there.
Yes. Thank you, sir.
Hello, Mayur sir.
Hello, ma'am. Am I audible you?
Yes, sir.
Yes,
Okay.
sir. Yes.
Okay. I think so. We start right now. Just a minute.
Shall we start, sir?
Just a minute, ma'am. I'll call the Dr. Sanab, sir. Just a minute. We'll start in 5 minutes. Actually, there was some connectivity problems. That's why we are getting some delay.
Yes, everyone. Am I audible, Dr. Mayur?
Yes, sir. You're audible, sir. Yes, sir.
Achha.
You're audible.
Are you waiting for someone or you want to start?
No, no, sir. We want to start right now. We are going to start right
Okay.
now.
Okay. Let's start then.
Yes.
Okay. Warm welcome to everyone and good afternoon. You are cordially invited to this inaugural ceremony for the 2 weeks International Faculty Development Program titled as Robotic Vision using ROS and the Machine Learning. I, Professor Neha Zope, warmly greet everyone and welcome to this platform of the Faculty Development Program. This program is scheduled in between the duration of 3rd October to the 15th October at MIT ADT University. MIT ADT University is a place where creativity and innovations both coexist and thrive. The innovation technologies and emerging trends among the all. It is located at the Rajbagh campus, Loni Carpo. It is my privilege to say that my campus is award-winning campus spanning over almost the 150 acres of the greenery and the inspiration. We, the Department of Mechanical Engineering, as a part of MIT School of Engineering and Sciences, has organized and put the efforts for this program, that is 2 week International Faculty Development Program on Robotic Vision using ROS and the Machine Learning. Keeping in mind the traditions of the Mayas, we will start our program with the beautiful prayer, that is World Peace Prayer. I request the technical team to play World Peace Prayer.
आवाज नहीं है सर.
Just a minute, I'll reshare again.
नमो जियाद्या वेद प्रतिपाद्या जय जय स्वसंवेद्या आत्मरूपा देवातूति गणेषु सकलार्थमतिप्रकाशु म्हणे निवृत्तिदासु अवधारी बोधी गुरुर्ब्रह्मा गुरुर्विष्णू गुरुर्देवो महेश्वरः गुरु साक्षात् परब्रह्मा तस्मै श्री गुरवे नमः। पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते। ॐ शान्ति शान्ति शान्तिः।
Thank you, technical team. The words of this word peace prayer, it always sounds the absolute peace in everyone's mind. Now proceeding towards the session, dear participants, the dignitaries and the esteemed faculty and all our well-wishers, let me have a privilege to say that with the blessings of our Honorable Professor Dr. Nath Vishwanath Karar, founder MIT Group of Institutions, Chancellor and President MIT ADT University Pune, with the blessings of Almighty, at the same time the guidance and the chief patrons of the today's program, that is Dr. Mangesh Karhad sir, Pro Chancellor and Executive President MIT ADT University, along with the Dr. Sunita Karar, Executive Director, and Dr. Rajesh S, the Vice Chancellor MIT ADT University Pune. So these are our basically the guiding lights who are going to guide us for this particular FDP, the dynamic leader Dr. Sudarshan Sanav and Dr. Ramchandra Pujari. There is always required a particular direction to be directed, and with the underneath of the umbrella of Dr. Sachin Pawar, we have successfully executed this today's program. And yes, with the help of you as an audience, as a participants, we will truly make it as a successful until the 15th October 2025. So this faculty development program brings together the researcher, academicians and the industry experts from across the globe to share the knowledge and advance research to this particular platform, and hence to deliver the welcome address, may I request Dr. Mayur Sawant to have a few words, to share the few words among us.
Thank you, ma'am. Thank you so much. Respected chief patrons, Honorable Professor Dr. Vishwanath Karat sirs, founders, members of the MIT Group of Institutions, respected Professor Dr. Mangesh Karat sir, Executive Presidents of MIT ADT University, respected Professor Dr. Rajesh S sir, Vice Chancellors MIT ADT University, respected Professor Dr. Ramchandra Pujari sirs, Professor Vice Chancellors of MIT ADT University, and respected Professor Dr. Rajni Sachdev, Dean Academics MIT University, as respected Professor Dr. Sudarshan Sanav sir, Dean Academics of the Faculty of Engineering Sciences MIT University, and respected Dr. Sachin Pawar sir, Head of the Department Mechanical Engineering. So all the respected deans, faculty members, and the experts, and all the dignitaries, and all the guests, and welcome to Dr. Sagar sirs, Professor Sagar sir. A very good afternoon, everyone. On behalf of a School of Engineering and Sciences, Department of Mechanical Engineering, MIT ADT University, Pune, it gives immense pleasure and to warmly welcome you all to you in this inaugural ceremony of the 2 weeks International Faculty Development Programs on the robotic visions using robot operating systems and the machine learnings. So these faculty development program has been designed to provide in-depth knowledge and hands-on exposures, as well as industry academia insights in a rapidly advancing field of the robotics, as well as artificial intelligence. So robotics today is not just limited to industrial automations, but has become a crucial part of the healthcare, defense, mobility, manufacturing, in any number of the applications where we need some solutions. So with the integration of the ROS systems, that is nothing but the robot operating systems and the machine learning systems, are become more intelligent and adaptive and capable of solving the complex real-world challenges. So we are honored to have a distinguished panel of expert resource persons who will be the guiding our participants throughout these programs. Dr. Arshdeep Singh's experts in the robot operating systems will provide the deep insights into the robot programming and the middleware integrations. Then Dr. Ribi Sirs, who is a specialist in the vision systems, who will share knowledge on the computer visions and robotic perceptions. Dr. Santa Kumar sir from the IIT Palakkad is very beyond mechatronics robotics, who will explain the kinematics, dynamics, and the control mechanisms, basically. Further, on the Dr. Hota sirs, who is expert in the machine learning, will bridge some algorithms and the robotic intelligence, basically. And Dr. Sagar, who is an expert, is the machine learning, digital twins, and the manufacturing. He's our today's chief guest from the University of Ulster, as well as Dr. Deepika Nikam. She is an expert in the digital technology. So she will demonstrate how virtual replicas can enhance the predictives and the maintenance and the system optimizations. So this FDP is an opportunity for the faculty members, researchers, and the industry professions to not only gain advanced knowledge, but also collaborate with some industry and contribute towards the innovations in the robotics and the AI. So I take this moment to express my heartfelt gratitude to our patrons, chief patrons, management, deans, sirs, faculty members, HOD for their constant supports and encouragement in making these programs in the reality. And especially thanks for our obviously conveyor coordinators for their dedicated efforts and organizing teams. So with these words, I once again welcome all of you and look forward to enlightening and the fruitful programs ahead. Thank you. Thank you so much, everyone. And welcome, Professor Dr. Sagar Nikam, sir. Ma'am, please.
Yes, thank you very much, sir. So we also warmly welcome the chief guest of the today's program, Dr. Sagar Nikam. Northern Ireland. He's basically working in the Ulster University. So good morning, sir, and warm welcome to this MIT ADT University's platform. So again, proceeding towards the next session, may I request Dr. Sujit Kunde, sir, to have insights about this program.
Sir, you are
Hello,
not
good
audible.
afternoon.
Yes, sir.
Can you hear me now?
Yes, sir.
Yeah,
You
I could log in from my mobile, so I'm speaking from my mobile.
Yes, sir.
Okay. Hope I'm audible to you. Honorable Dean of Faculty of Engineering and Science, Dr. Sanap, the chief guest of today's function, Shri Sagar Nikam sir, all the team behind this program of robotic vision using ROS and machine learning, and all the participants from different dimensions of professional organizations. I must congratulate you all for participating in this very, very important event. First of all, my word of admiration to Dr. Mayur Sawant for bringing all the community together on one single platform and giving everybody the opportunity to learn these very important concepts with which we are taking forward the mechanical engineering dimension. I will say that now I'll not elaborate much, but what I feel is very important. Mechanical engineering has evolved in different contexts with different perspectives, I'll say. So in industry 1.0 to Industry 2.0, Industry 3.0, and now we're into Industry 4.0, where robotics, automations, and all the terminologies which or tools which we feel are important are amalgamating together all the technologies. So mechanical engineering cannot be seen in isolation. It is amalgamation with all the IT and technologies like this robotics, machine learning, AI, ML, embedded systems, IoT, cyber security. And if we do not learn this today, then we will be missing the very important aspects with which we cannot catch the pace of the time. So it has become the need of the time. Also, the applications can be visibly seen in different industries, and it also gives opportunity for teachers to participate and contribute with their knowledge and wisdom. And second, also for the students to make this as a point of their career aspirations. So we are into exciting times, and I look forward for a very interactive sessions forward. And I think it is going to be a very wonderful session. We'll be grasping very important concepts of this robotic vision using ROS machine learning, and I personally am excited about attending few sessions of it. Again, I must congratulate to the entire team behind this event, and wish you a very good time and a fruitful time ahead. Thank you, Dr. Sawant, and thank you, Madam Zope and the entire team. Thank you so much.
Thank you, sir. Thank you so much for your sessions.
Thank you, sir. Yes, as we truly believe in the amalgamation of the and the importance of the mechanical engineering, hence from different areas, the various faculties have joined our program, and definitely the Dr. Mayur Savant has already elaborated all these things. So now again proceeding towards the next step of this program, let me now take a moment to hear and learn from the dynamic leader the various perspectives of our Dean, the Faculty of Engineering and Sciences, Dr. Sudarshan Sanap, to share his insights with us.
Okay, thank you, Professor Neha. First, I would like to welcome all the national as well as international participants for this 2 weeks international faculty development program on robotic vision using robot operating system and machine learning. It's very, emerging topic when we talk about this new world which is moving towards the digitization. This topic is very relevant. Let me appreciate Dr. Mayur Sawant, Dr. Pratik Joshi, Professor Ashish, Professor Ashwin, and all the team members from this division of robotics and AI. They have chosen this topic, and which is very much essential that not only the students but faculty should also understand what about the importance of this emerging topic. Rightly said that nowadays when we talk about system engineering, it directly goes towards the multidisciplinary approach where the role of mechanical engineer, civil engineer, electronics, computer science background. So they have to work together and come with the ultimate, the goal or the objective of that particular product. As we are in academics, so our ultimate agenda is again in the similar way that our student should be a multitasking engineer at the end. Accordingly, we are generally organize such programs. Thanks to the management, special thanks to Dr. Mangesh Karat sir. He has developed a very beautiful campus across 140 acres in this part of this world, that is in Pune. My sincere appeal to all the national and international faculties, please visit once when you'll get a time to this campus. This FDP, even though it is mentioned through online mode, and Dr. Mayur has mentioned that a lot of hands-on are also going to happen during this journey. My appeal to every participant that I can see around 100 plus participants are there now. my appeal to every participant, take the benefit of this, discuss with each other. You do have a lot of, that resources are there. And if you talk about resource persons, so we can see that lot of national as well as international expertise are there. Share your knowledge with them and try to take the maximum benefit of this FDP. Thanks to Dr. Sagar sir, who is the chief guest of this session, for being a part of this and going to share his knowledge about this topic with all our participants. Ultimately, my appeal to everyone that discuss with each other, form a group, and work together for the benefit of the society, and specifically the robotic society, so that everybody will feel proud that because of this or such kind of workshops or the faculty development programs, I'm getting such knowledge and my knowledge is useful for the society. So with this appeal, I would like to stop over here and best wishes to all of you. Thank you.
Thank you so much, sir.
Thank you, sir. Thank you so much, sir. So that was a truly inspiring the words that we received from Honorable Dean Dr. Sudarshan Sanav, sir. Now, I will like to introduce the chief guest of our today's program, Dr. Sagar Nikam. So, Dr. Sagar Nikam, he is a distinguished academician and a researcher who is currently serving as a professor at School of Computing, Engineering and Intelligence System at Ulster University, which is located at Northern Ireland, UK. He is a chartered engineer registered with the Engineering Council UK, a member of Institute of Mechanical Engineering and a fellow of the Higher Education Academy. His research expertise spans additive manufacturing, process simulation, modeling, in-situ process monitoring, AI integrated computer vision, and digital twin-based systems. He has successfully supervised the doctoral, master's, and undergraduate theses and contributed to the numerous internationally funded research projects, including EU collaborations and international science partnership funding initiatives. Dr. Sagar Nikam has authored and co-authored the multiple high-impact publications in reputed journals such as Additive Manufacturing, Progress in Additive Manufacturing, the International Journal of Advanced Manufacturing Technology, and the Machines. His work has advanced our understanding of the laser-based power bit fusion, wire arc additive manufacturing, and real-time defect detection using AI and computer vision. He has been invited worldwide to deliver the expert talks and the keynote lectures on the topics such as the smart manufacturing, digital twin systems, and AI-driven process monitoring, with recent engagements in South Africa, India, and across Europe. So for his excellence, he has also been recognized among the top 10 engineers graduating in production engineering from the Shivaji University. So literally kudos to you, sir. And it is indeed our privilege to have you, such a visionary scholar and researcher, with us today as a chief guest. So let me congratulate you, sir, being a top 10 engineers in worldwide from the Shivaji University. And once again, I like to ask you to extend your warm welcome as a chief guest to our audience. Over to
Thank
you,
you.
sir.
Thank you very much, ma'am, for this brief introduction. And special thanks to the team over there at MIT for giving me this opportunity as a chief guest to inaugurate this the 2 weeks international faculty development program on the robotic vision using ROS and machine learning. It's really very a privilege for me to give this 2 minute talk or some few words on this particular program there. And I really see and I really feel proud that the MIT ADT University is taking this technology to the next level, because I myself have been like been in India for like I studied my engineering, my PhD over there, and like this is something new I experienced there. Like the people, the students, the researcher, the industry persons in India are getting the next level of knowledge where the robotics visions are being used for different aspects, whether it could be like manufacturing or industries, or it could be the doctor or medical, different aspects there. And another thing is that it's integrated with the AI and the machine learning, whatever technologies are being there. And it's really very proud moment to say that this particular team at the MIT Education University, specifically based at the School of Engineering and Sciences, with it and the Department of Mechanical Engineering, and their head, Professor Dr. Sachin Pawar, and the patrons, Professor Dr. Sudarshan Sanap, and Dr. Rajnish Sachdev, and Professor Dr. Ramchandra Pujari. All this are really very the guiding people over there, and making this technology enable for the engineers, for the researchers, and the industry person there. And special thanks to the Dr. Mayur here. I know I'm having special relation with him, like in case of like research and all those things. We have been working together from years, and it's really very much, Dr. Mayur, that you are taking this technology, you and your team over there are taking this technology of robotics to the next level and integrating it with the AI and all those things. And obviously, like I'm just giving a talk here, but I will definitely giving a talk on some aspects in the coming days, some related to my research expertise here. I'm not going to take much more time on that. Like, all right, so thank you very much, the team over there, for inviting me and giving this opportunity to inaugurate this particular session. And I really appreciate, and I really give my best wishes to the team over there. And I can see already this particular session program is like more than 100 plus. It's like really a good success for the team there, and I really wish my best wishes for this team to for this particular successful of the program there. Thank you very much, ma'am, and thank you very much, Dr. Mayur sir, there.
Thank you so much, sir. Thank you so
Thank
much.
you. So it was really a very short and the sweet words that really enlightened us. Thank you very much, sir. So now I like to proceed in the next session. So with the due permission of all dignitaries, Dr. Sanab, Dr. Funde, and the Dr. Nikam, shall we start our first sessions of this 2 weeks international FDP?
Yes, ma'am.
Okay.
Yeah, yes.
Go ahead.
Okay. Thank you so much. So, ladies and gentlemen, let us start towards our first session of this FDP. So, for that purpose, we have with us the Dr. Arshdeep Singh. So, let me take a privilege to introduce the Dr. Arshdeep Singh. So, when I gone through his biography, then I like to mark a comment that from lab to the live environment, the person who is living, that is none other than the Dr. Arshdeep Singh, who builds a system where robots don't just plan, but the robots perceive, adapt, and coordinate. He has engineered a cross-domain delivery platform on Husky 8200, melding ROS2 navigation with RTAB map for the loop closure aware SLAM, enabling robots to guide from tight indoor corridors to open corridor system quartz without a pause. He also has engineered a warehouse autonomy that couples NavTools planners and controllers with a SLAM toolbox mapping and AMCL plus odometry IMU fusion of the rock solid pose estimates, because the safety and repeatability matters a lot. A reusable multi-sensor fusion stack who played the vital role in designing in the career of Dr. Arshdeep Singh, that integrates basically a LiDAR, GPS, and IMU into the ECAP driven localization, which was validated via ATE analysis script for transparent and the data driven performance. His research canvas further includes the Lyapunov stable leader follower formations, the feedback linearized, and the backstepping control for under actuated marine vehicles, reactive obstacle avoidance with DMM, and the ROM executed task allocation for multi-robot team. So currently Dr. Arshdeep Singh, he is working as a professor at Indian Institute of Technology, Jodhpur. So welcome to this platform of 2-week international FDP program, Dr. Arshdeep Singh. Are you there in the session?
Yes, ma'am. Thanks for such a great introduction.
And yes, without wasting a time, we will like to hear you on our first topic of the today's session. So
Yes.
Excuse
I'd
me.
like to hand over this forum to you, sir.
Excuse me, ma'am. I think Sachin Power sir is there. He want to talk something.
Ma'am,
Sir, sorry, Dr. Ashdeep Singh sir and the audience. Let us have a pause. We are also among with us. We are being honored to have our head of the department, truly the director behind this program, Dr. Sachin Pawar sir. May I request Dr. Sachin Pawar sir to share his insights among all. Hello. Hello.
Yeah, I think sir is unable to connect. We can proceed.
Okay. Fine. So, shall I, sir, with your due permissions from the coordinators and the dignitaries of this program, shall we proceed towards our session?
Yes,
ma'am.
yes.
Okay.
Yeah, Arshdeep sir.
So,
Over to you.
yes, Arshdeep Singh sir,
Uh,
over to you now.
can I have the access to share my screen so I can
Yeah, you
show
can
the.
share.
But here it is showing that only meeting organizers and presentators
Just
can
a
share.
minute. Just a minute.
Yeah.
Hello, good afternoon, sir.
Good afternoon,
This is,
sir. How are you?
this is Dr. Yes, sir, I'm good, sir. And warm welcome to this faculty development programs. And
Thank
really sorry, first of all, for the such a little bit delay. So session was starting almost around at 2 o'clock, but it is almost 15 minutes late. But you can, sir, you can take more times for the tech sessions.
Give me a minute. Give me a minute.
Yes.
No issue. It happens sometimes.
Check now, sir.
Yes, I got the permission.
Yeah, we can see you, sir.
Yeah. So. So I am audible and my screen is visible.
Yes, sir.
So let's start with our first session on ROS, Robot Operating System. Myself, Ashdeep Singh from Indian Institute of Technology, Jodhpur. So in these 5 sessions, I will be talking about a robot operating system. So in the first session, I will be covering what is the meaning of the ROS, why we need it, what is the philosophy behind designing the ROS and developing it, what are the prerequisites uh, for jumping into the ROS, and what is its architecture, and what are the resources that we can follow for learning the ROS and begin our development into the robotics. So basically, ROS, we can split it into two terms, robot and operating system. So we will look one by one to the both terms. What does robot mean? What does operating system mean? And what does, by combining both robot operating system, what does it actually mean? So for robot, the standard definition of a robot is an autonomous machine capable of sensing its environment, carrying out computations to make decisions, and performing actions in the real world. So, if we have to split the robot into parts, then basically it has three major parts. One is performing actions, second one is decision making, third one is self and environment perception. Now, what kind of actions a robot can perform. Like as the robot shown is an mobile robot with a manipulator. For this robot, the action can be going from one place to another place, like moving from point A to point B. And for the manipulator part, the task can be like manipulating a object, like picking an object. So the second part is decision making. In decision making, basically we need to figure out what to do and how to do. Like if the robot has to move from point A to point B, then there are other parameters that we need to figure out also. Like how fast do we need to move from point A to point B? Is the environment static or dynamic? Like is there any other movable objects that maybe a, come between the point A and point B? How many paths are possible from point A to point B, and which path we have to choose from point A to point B. So in the third part, self and the environment perception, uh, basically we do this part to figure out some questions. What are those questions? Like where am I? How fast I can go? Have I reached the goal? Can I move forward? So to answer these questions, for a robot to know these, robot needs sensors. And some of the common sensors are IMU, LiDAR, camera, GPS, encoders, etc. And uh, quality of sensors and number of sensors depends on the application where we want to use our robot and how harsh environment it is going to face. So let's talk about the complexity of the robots. Are robots complex systems? Yes, definitely. As robots include concepts from different engineering backgrounds. Like for the decision making, we need to figure out the concepts from AI and computer vision. For the manipulation, we need to work on the electromechanical systems. And individually, systems are these systems have huge depth. They are individually much complex. But for a robot, we need these to operate together. So this increases the complexity of a robot. It makes it a complex system. For like in the image, you can see it in very simple scenario. You need sensors to perceive the environment, to sense its internal states, like camera, lidar, IMU. Then from these sensors, you need to robot need to figure out like where am I, need to make plans, then those plans need to be executed with the help of the controller. So it makes it little bit more complex systems Apart from that, there are other challenges, like we can't expect delay in robots. They should be real time. We can't wait that okay, I will take a robot will take 5 minutes before deciding that it will choose path one or path two. It should be instantaneous and real time because they are going to operate in the real environment. So that makes them much more complex. Now let's look at the second part, operating system. We all are familiar with the operating system. We are currently being connected with the help of an operating system via all our devices. So, formal definition of an operating system is software that enables users to run other applications on a computing device. The computer operating system acts as the interface between hardware and software, managing system resources for execution of installed programs. It is the backbone of any computing device. So, like we normally use Android for our smartphones, Windows for our laptops, or Linux for our servers or laptops. So basically, what they do, they manage resources, our computing resources, how much memory should be allocated to a particular program. They help us to connect external devices, which can which can help us to give input to our software. They helps to integrate hardware and software to access storage devices, to access networks, and etc. So why we are discussing about the operating system here? As an operating system is interface between the software and hardware, and we already seen in a robot that there is hardware part, there is software part, there is computation part. So we need to make we need to we want that all these components should come together and work as a single system. So that's why we are discussing here about the robot operating system. Now you may have some questions like why dedicated operating system for robots, how it is different from the available operating systems, like the operating system we are using, like Android, Windows. It is not doing something real in the environment. It is not manipulating environment. If our system crashes, there is no harm to any human or in any actual environment. But robot is an
Yeah, dear participants, just wait for a minute.
oh, sure. Am I audible?
Yes, yes, sir.
Yes. So I am sharing my screen and repeating one, two slides. So if
Yeah.
you have any doubt, we can discuss at the end, and I will be sharing some resources so we can connect and discuss about the ROS. So at the end, I will share uh, my GitHub link in the chat bot. So even after the session, if someone has query about the ROS, then we can discuss on GitHub.
Yes, sir, sure, sure.
So we have so far seen what a robot is, what operating system is. Now, why we need dedicated OS for the robots? As current OS is is not designed for the robots. They are like general purpose operating systems. But for robot, we need something to that can work in real time, that can handle the complexity of the robotic systems. As like there is complex systems requiring different type of configurations. Now, how it is different from the available operating systems? Like we have Windows, we have Linux based operating systems like Ubuntu. Here ROS provides us an ecosystem and framework which helps us to work with robots in very much easier way. It basically abstracts many things for us. We will see what does it mean in upcoming slides. So, what is ROS? Framework to reduce the complexity for designing, making, and operating robots. The basic philosophy behind designing the robot is it is real-time, distributed, scalable, and it is open source. Like the source code for the ROS is available for everyone in this world, and we can modify it, use it as per our requirement. It is available for all sort of robots. It may be a legged robot, it may be a wheeled mobile robot, it may be a robot operating in a hospital, it may be a robot operating in outer space. So ROS is available for all sort of robots. Apart from just robots, as we have seen, robots are complex systems requiring different uh, components. Like they need computing power, they need algorithms to make decisions, they need manipulators to actually manipulate something in the environment. So like if I say for mobile robots, the basic purpose of mobile robots is like moving from one place to another place, carrying some load. So for that we need navigation, and there is a dedicated navigation stack that is based on the ROS, that we call it nav1, nav2. Similarly, for the manipulators, there is dedicated stack, move it and move it to. So ROS is helping us to integrate our needs for from the robots into one framework. So using one framework, we can, like if I want to talk about the vision, then we all know there is one library, famous library, OpenCV. We will use OpenCV. So ROS has integrated OpenCV within with its ecosystem so that it becomes easy for us to integrate our needs in the robots. We don't need to build robot from the scratch. We can use other person's code. Like if I have solved a particular problem, then another person doesn't need to start from the scratch. He can use my code. Similarly, robot the ROS has developed such libraries that are available to all, available to different kind of robots, like uh, ROS to control or ROS control. Every robots need control, be it a manipulator, be it a wheeled mobile robot. It may be of different types, like it can be a differential drive robot. It may be an omnidirectional robot. So do we need to start from the scratch? No. ROS provide us help to avoid starting from scratch, because it is complex system, it will be frustrating and time consuming. ROS provides abstraction from that complexity and helps us to start our work. If I am working on a control system, designing control system for a robot, then I can work on that part, and the rest part ROS will help me to figure out it easily. Similarly, if I am working on a vision part, then ROS will help me to figure out with the algorithms, decision making part, and control part. So ROS. ROS is not an ordinary operating system. It is based on the another operating systems. It is available for Mac, it is available for Windows, it is available for Linux based systems like Ubuntu. But it is majorly, it as it is open source system, it is majorly based on Ubuntu Linux based system. So all the development of the ROS is majorly done based on the Ubuntu, and all the practical use cases where we actually deploy ROS on the actual robots, we use a Linux based Ubuntu server. So before going into like starting with ROS, as it is definitely an operating system. So we need to figure out how to interact with it. It is based on another operating system, which is Linux, and it is not that much common operating system for normal users. So to begin with ROS, one should have familiarity with the Linux based operating system, mainly Ubuntu. For both cases, server and GUI, we normally use GUI based operating systems, but here for deployment purposes, we should be getting hands-on with the server-based operating systems. Then we should know programming, like basic to intermediate. The ROS is available in basically two programming languages, Python and CPP. There are two major libraries, RCL CPP, RCL Pi, and now the ROS is also working with Rust. It has open source a library based on the Rust. So apart from languages, apart from operating system, one should have basic familiarity with the robots, also basic mathematics like frames, transformations, if depending on the what kind of robot, like mobile robot, manipulator you are working. Apart from that, you should have the clear goal, what you want to do with uh, in a robot. So according to that part, you will be working with ROS, as ROS is an whole system. So you have to decide which part you will be working, but you should have the knowledge of the other parts also. You need not to do development, but should know how to use that parts. And I will be in the next sessions, I will be covering different aspects of the ROS. So you should get familiar with the all the aspects, and then you can start your development in your particular part, like vision. So as I have already told you, ROS itself is a complex system. You have to decide how you want to use it, how you want to approach it. You want to be a user, you want to be a developer. There is a common misunderstanding, like it is an we get excited about it and we want to learn more and more and more, but the learning curve of the ROS is very steep and it is not easy, it is frustrating. So you have to decide if you just want to be a user who knows how to use ROS for and robot, or you want to participate in the a ROS development, robotics development, or like if you are an researcher who has developing some algorithm and who want to test it in simulation or in the real on the real robot, then he will be treated as an user, and he should have basic knowledge about the ROS different aspects, how they will be integrated for development of the robot, and then he should focus on the its part which he's working on, which is he's developing. For the developer part, he has to go in much depth. And in these sessions, I will be focusing the sessions basically based on the treating you as treating all as a user for the ROS, and we will be keeping it basic and at an beginner to intermediate level. So let's see the official documentation of the ROS. As I have already told you what ROS is, what does robot mean, what does OS mean. Let's see what the official documentation of the ROS says. So let's search ROS. We are going to the home page of the ROS. So what does it say? Robot operating system set of software libraries and tools that help you build robot applications, from drivers to state-of-the-art algorithms, and with powerful development tools. ROS has uh, has what you need for your next robotics project, and it is all open source. That is all that we have discussed in recent time. Okay, how it is helping us to start our robotics development. And second thing, it is open source. So it is free to use, free to develop it further. It is community-based initiative. So another confusion about the ROS is which operating system to choose. Like it is available for Windows, Mac, and Linux based Ubuntu operating system. So most of the development is done using Ubuntu. So that is also an open that is also freely available OS. You need not to have pay money for using that. So if you have like a Windows system, Windows laptop, then you can do dual boot within Ubuntu. Ubuntu also itself has versions like Ubuntu 22, Ubuntu 24, then recent release is Ubuntu 25. Before deciding the Ubuntu, you have to decide what version of the ROS you are using. As ROS is an open source system, it releases many versions like long-term support versions and short-term support versions. We will be using long-term support versions, and for these sessions, we will be working with ROS 2 Humble. There are two versions, ROS and ROS 2. ROS is not available now. It has reached the end of life, but ROS 2 is the like that is currently under development. There are multiple versions inside the ROS 2. Like you can see, there is the latest release is Kilted, then there is Jazzy, then there is Iron that has reached end of life. So uh, as per ROS to Humble has been well established for all your needs, like working with vision, working with navigation, working with state estimation, working with control. So it is easier to get started. If we are starting our robot operating system journey, then it is easier to start with uh, ROS to Humble, as it provides us uh, it is easier because multiple developments has been already done based on the based on the ROS to Humble. So I am pasting this official web documentation page in the chat box, so you can visit this, and after the sessions you can see what it is, what are its components, and we will be following the official documentation for our further sessions, doing with hands-on. Also, if you all have laptops, and it will and you can do the dual boot with Ubuntu, then it will be easier and much fruitful for all of us to get started with hands-on rather than just listening and seeing what ROS is, how it works. And so in the next session on Monday, if it is possible, if you can bring your Linux system, then you should bring. Now I will move to the documentation, and uh, let's start with you can do the installation part by yourself. I will just tell you. uh, you can visit the installation page. There are multiple ways we can install a ROS. So as per the documentation for Ubuntu Linux, the compatible version of the Ubuntu is Jammy Jellyfish 22.04. So to use ROS to Humble, your device should be running Ubuntu 22.04 Jammy Jellyfish. So apart from that, as it in Linux system, you should have some pre understanding of the Linux systems. If you like you face difficulties in that Linux operating system, so before the next session, please let me know. I will just uh, do an hands-on introduction to Linux for 15 to 20 minutes, so it becomes easier for all of you to like uh, get started. For installation, we will be using deb packages. There is another option of the binary archive, but deb packages is much easier. So you don't have to worry about. All the instructions are mentioned on the official documentation, and it is well defined, and you have to follow all the instructions of this page, Ubuntu install page. So uh, next steps after installing, we will start our next session with demonstrations from after the installing the uh, ROS to Humble and getting familiar with the Linux. So we have seen a robot operating system, it's how it is complex. So how actually ROS is helping us here? How it is reducing the complexity? To answer that, let's see the architecture of the robot operating system. It has a complex architecture, but as a beginner level, I will be keeping it very straightforward and easy. So to reduce complexity, ROS uses nodes. All the complexity is divided into nodes. Each complex component represents a node in robot operating system, like camera, IMU, lidar. These are all are sensors. So there will be one node for camera where you will be getting data from the camera. Then there will be another node uh, responsible for handling lidar data. Then there will be another node which will be like getting data from the sensors and doing planning part. Then there will be another node which will be doing the controlling part. So all the complexity of the robot is divided into nodes. Each node in ROS should be responsible for single modular purpose, like controlling the wheel motors, publishing data, and doing only one sort of particular task, so that it does not become does not become a complex system. So what ROS is doing, just breaking down the complex system into the nodes, and we can, if we need to debug something, we can figure out which node is malfunctioning, where the problem is. So we need not to worry about the another components. Each component has a node. Now the components have been divided into nodes, but these should act as an whole complete system. For these to act as an whole system, what we need? We need nodes to communicate.
Excuse me, sir.
Yes, sir.
Your PPT is not visible. We can see only ROS window.
Okay, just a minute. Is it visible now?
Yes, sir. Yes, sir.
Yeah. So basically, ROS is helping us to reduce complexity by dividing the system into nodes, and each node is responsible for doing some particular task. And for system to act as a whole, we need that these nodes should communicate. And for communication, ROS offers basically three ways, which we will see in the next slides. First way is topics, services, and actions. These are like easier to understand, little bit hard to implement. We will be doing hands-on by making notes and then making them communicate with each other. So first way of communication in ROS is topic, second is action, third is service. So let's first understand what is the topic, publisher subscriber type of communication in ROS. So as we have seen, two nodes need to communicate. For communication, we need some message that should be transferred, that should be passed. So here you can see there is one publisher, one subscriber. Publisher means who is sending the data, who is generating the data, subscriber who is consuming the data. They are communicating a particular message on the topic. Next part of the topic is that they can be n number of publishers, n number of subscribers. So it is not one-to-one communication. It can be one to many, many to many type of communication. There can be multiple nodes. They may have uh, a node can act as a publisher and subscriber itself. It is possible that a node is sending some particular data and also receiving particular data from another node. You can understand it is like an broadcaster system. The message from the publisher node will be just broadcasted, and any node who wants that message can subscribe that particular topic. Each topic will have particular name. So it is basically like I am speaking, I am publishing on this conference call, others are listening. So what basically I am publisher, and all the audience is subscriber, because I am generating data, I am giving data on a particular topic, and all others are listening, they are subscribing. So this is like very abstract way of understanding things. We will go in uh, go in depth, then we will understand how does it look on the actual robot operating system. So another part is service. How does it is different from uh, broadcast type of communication? in broadcast type of communication, anyone can listen. But in this, if a request will be raised for communication for a particular message, only then the response will be provided. So as there was subscriber and publisher, here we have client and server. We basically say service client and service server. Service client has to raise a service request like from camera if we want to get data. Normally camera based communication is based on publisher subscriber. Any node can like get the camera data. But if we don't want that, we want that it becomes available only on the request. Then camera node in service based communication will be service server, and the node which will be requesting the data from the camera node will be called service client. So service client has to request for the data, then service server will provide the data. Now it is not necessary that data will be provided just as the request is raised. There may be some time. In that time, service client has to wait until the message from the service server is not sent to the service client. Then all the communication like will be halted. The service client will be waiting for the response from the service server. So if we don't want that, we don't want to wait from for the data coming from the service server, then there is another type of communication which is action based. How it is different from service based? There is only one difference. There is feedback. If I am requesting data from camera, then if camera is not giving data, then it will give feedback. Like data will be coming in 5 seconds, data will be coming in 10 minutes. Another example of the action based communication is in navigation. Like a planner node has given has figured out a path that a robot should follow. Now, to follow a path, a robot will take some time because to cover a path, time will be taken. But the ultimate goal is to reach at the required designated point, say point B. So from starting point A to starting point B, there is some time. In that time, like if something unexpected happened, there uh, a robot got stuck. It can't move from a point in between A and B. Then we need feedback to resolve that issue. And that feedback is provided by this action type of communication. Here, continuous feedback is provided by the action server to the server client. So that action client can figure it out for the long running tasks. We will also see its example, and the as I already said, there is a navigation stack nav2 for ROS2, and that stack is based on that this action client action server communication type. So and that's basically all for the today's session. I will be sharing a GitHub repo. I have opened the discussions on this GitHub repo. Like if you are having problems with dual booting your system or installing ROS and figuring out how to get started before Monday session, so you can just do your comments on this GitHub link that I have shared. So I advise you to follow to see the ROS2 documentation. I have spent 2 days session to just introduce what ROS is, so that you can get clarity why we are using it, how it is solving our problems before jumping into how it works. So I hope you have got some idea about the ROS. So if you have some queries, then you can ask me. And if you have later on some queries, then I have shared the GitHub link in the chat. So you can just come and comment, and I will respond to that. So any questions?
Dear participants, forum is open for you. If there are any questions, kindly unmute and ask the question.
Sir, I
Excuse me,
have
sir.
one
Hello.
question. Yes, sir.
So can we learn
Myself,
it graphical way?
Uh, what do you mean by graphical way?
So means GUI either or we work should with the CLI only.
No. We will start with the GUI itself. Then in intermediate level, we will work with the CLI. So we will start basically with the combination of the CLI and GUI. So like if you are operating your Windows system na, and you don't like you mostly work with GUI, you don't use CLI, but in this we will use CLI and GUI both, but for deployment we only use CLI. So in the next sessions we will be using combination of both GUI and CLI. I hope you got your answer.
Yes.
So, does everyone has an Linux-based machine with the Ubuntu 22.04?
Almost already uh, almost all our participants. I think so. Almost all participants have this Ubuntu because already we informed them about this
Okay, so they have
resources.
basic introduction with the Linux CLI, or should I give 20-25 minutes in the next session to introduction to Linux CLI?
Yes, sir. It will better too because there are the many students who are first times they are working on it.
Okay, then in the next session we will first start with the Ubuntu 22.04 basic Linux commands like changing directories, accessing files, accessing folders, making folders, deleting files. These
Yes, sir.
basics. So it will be better if we can all do all together. So I will next time I will be representing from the Linux system, and we will be doing hands-on all together. So uh, I think that's all for today's session.
Okay. Uh, Participants, anyone has query, questions?
Excuse me, sir.
Yes.
Yes.
Sir, I have a question on Ubuntu. Like, still now I didn't install Ubuntu OS.
Yes.
So if I want to install, should I go for a dual boot or should I install VirtualBox?
You should go for the dual boot if your system is not encrypted or you are not facing that kind of difficulty, because virtual machine will make your system slow, so it will not be that responsive as two OS will be sharing the same resources. So if you can go for the dual boot, then dual boot is the best option. If not, then can work with the virtual machine for starting.
Okay, sir. Thank you, sir.
Sir,
Yes.
there is a question on the chat bot.
Yes, we can use WSL for ROS to Humble using Windows, but the setup is complex. So I don't advise to get started with the WSL. So because ultimately we will be porting to Linux, and if we are going to deploy something, doing something in actual practice, so it is advisable to just uh, get your mind ready to go for Ubuntu, and if you can uh, go for the dual boot system, then it will be best uh, for, like, if you are want to continue using ROS and being in the robotics work space, then I advise you to go with the dual boot. But we can, like, adjust with WSL or virtual machine and these things also.
Any questions? Participants, any questions?
No, sir.
Okay, I think so. Everyone has understood everything. Yeah, ma'am, I will give some. Yeah. So thank you so much, sirs, on behalf of this organizing meeting, FDP, specifically on robotic visions. Specifically, I take this opportunity to extend my heartfelt gratitude for delivering such an insightful or enriching sessions on the robot operating system. So your expertise and especially clear explanations about these concepts about have not only introduced the participants to the fundamentals of the ROS, but also it's specifically to me have also sparked curiosity and interest in exploring some advanced theory applications at the hands-ons in the robotics and a practical perspective. Such you shared will guide our participants as well as our teaching endeavors. We truly grateful for the times, efforts you have dedicated to these sessions. We know that this, despite your busy schedules, even though you given such a times and efforts. So we look forward to you continued such a guidance, supports in the upcoming sessions. Uh, Thank you once again, sirs, for making these sessions very highly valuable and inspiring to us. Thank you so much, sir.
Thank you, sir, for this opportunity. I will say just one thing. ROS
Yeah.
is a community-based system. It is developed by the community for the community. So
Yeah.
I am just doing my part. So
No,
I
no.
encourage everyone
Mm.
to be part of the ROS community if you are working with the robots. It is the future and it
Yeah.
will be helpful. So thank you
Yeah.
for this opportunity, and it was nice to have you all.
Thank you so much, participants, and thank you so much, our guest. So I think we can leave this. So tomorrow also we have sessions at 2 to 3. The Professor Ribi from the IIT Jodhpur and from 2 to 3 and 3 to 4, almost 3:15 to 4:15. There are the two sessions tomorrow. He is giving some experts on the machine visions. I know that there is not a proper the way of a course structure, but it is again as uh, we schedule this total FDB coursework according to the experts availability. So I kindly consider this and hope tomorrow you will enjoy the another sessions on the machine learning and machine vision systems. And this ROS session again, it's the second session on the from the Monday, Tuesday, Wednesday, and Thursday as well. You can continue, you can learn, you can if suppose even though if you have any problems, any queries in your own project also, you can discuss with the Professor Dr. Arshdeep Singh also. So it I think so it is a very great. It was a great sessions, and it will help you in your ROS learning systems as well as in your projects problem statements also. Okay. Thank you so much, everyone and every participants. I think so you can leave.
Yeah,
Okay.
before
Folks,
leaving, I'll
yeah.
request everyone to switch on their cameras.
Yeah, please. Hello, Duval sir.
Just a minute. Huh?
Brani, you can switch on your camera if possible. Kenil. Okay, thank you so much, participants. Please switch on your camera.
Yeah, thank you all.
Thank you, thank you. Thank you, Pratik sir. Thank you, ma'am.
Thank you very much.